So remember how we talked about one usage of pattern-based AI is for prediction? Well, this pattern-based prediction technology can also be used in words and sentences. So if we give the system a bunch of words, it may be able to predict what the next word in the sentence may be. And one recent development in AI is to take this prediction technology and extend it into generative AI systems that can produce text and images, etc. But you might be able to recognize that they are based on predictive AI technology. We're going to take a closer look at generative text AI now, and we're going to see how it relates to the basic text prediction on your phones. So for example, here you're typing in an email, and as you go through and type the words, your phone is being helpful and suggesting what it thinks can be a suitable next word for you. So let's imagine all of the above sentences there form part of your history. The text prediction is going to use all of these sentences as data or as samples to help it predict what the next word could be. So here we're going to break down the history of your text messages into pairs of words. These are called bigrams, bi meaning two, and grams in this case meaning words. Let's start with the pairs of words, starting with the word for. So there they all are. For real, for real, for real, for reals, for real, for real. And what we're going to do is form a little table where we're going to count all the pairs of words where the first word is for, and we're going to count all the different types of words that come after the word for. So we have real, and there's 5 of those, and we have reals, and there's only 1 of those. So that's our first bigram. Now let's take a look at a second set of bigrams, this time with words starting with the word like. Here are all the bigrams with the first word being like, and we do the same thing. First word is like. There are 2 B's. There's 1 so, there's 1 bro, 1 how, and 1 actually. Let's repeat the process with the first word of a bigram being bro. When the first word is bro, we have like, it, and he, all occurring once. Now let's look at bigrams starting with he. He being the first word, wasn't, actually, thought, really ate. They all have a count of 1. Bigrams starting with the word be. In our history, there's only 1 other word that follows be, which is for, and that happens twice. And so what we're going to do now is summarize all of the bigrams we looked at there, and we're going to use these set of tables and counts to automatically construct a sentence for ourselves. And in our example here, we're going to start a sentence with the word bro. So we're going to look at bro, that's going to be our current word. We're going to look at our bigram tables, and we're going to see that these are the words that follow bro in our history. So what we'll generally do is pick the next word as the one that has the highest count. But in this case, they all have the count of 1. So we're just going to randomly pick a word here. So let's just pick like. So now we have bro, like. We do the same with the second word being like. Let's look at the bigrams that have words following like. We have these 5 candidates. Let's pick the highest one, which is going to be B. So now we have bro, like B. Let's look at bigrams following B. We only have 4, so that will be the word we use. 4. So you can see the sentence is slowly building up, and it's sounding like bro, like B4. And for the last word, let's look at the counts for 4. We have real and reals. Now, although we generally pick the highest count, in order to add some variation into the sentences that we produce, we don't always pick the top one. In this case, let's just pick the second one. So reals, and you can see by just going through this process of looking at the counts, picking the word that has the highest count or close to the highest counts, we've generated a brand new sentence, bro, like B for reals. And you can see that this new sentence does not occur anywhere in our history or in our training data, but it still sounds like it's in the style of the types of messages we've typed before. That is a very simple example of generative text based on text prediction.